We're starting Chapter 7 with Section 7.1, which is called Ratios and Proportions. We have 4 objectives, the first one being writing ratios from a word problem. Second one, using these things called extended ratios, which compare 3 or more numbers. The third one, solving proportions using cross multiplication. And the fourth one is writing equivalent proportions. So before we can begin, we have to know what a ratio is. So our first vocabulary word is ratio, a comparison between 2 quantities using division. Now, I can write these ratios in 3 different forms. The first one, let's say I'm comparing A to B, apples to bananas, whatever you want to compare. I can write it as A over B, A colon B, or the word to B. So we're going to do an example here. They give me a word problem talking about this bonsai bald cypress tree. It says the bonsai bald cypress tree is a small version of the full-size tree. A Florida bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator if the bonsai is 15 inches tall? Okay, so first thing I recognize is that they're asking me for the height of the bonsai. Oops, I forgot the N there. The height of the bonsai to, so that's my fraction bar, the height of the Senator. And they told me the height of my bonsai tree is 15 inches. And they told me the height of my Senator is 118 feet. Okay, so they gave me these measurements, but they're in different units. If you look, you've got 15 inches versus 118 feet. I have to make sure that my units are the same. So I'm going to continue that 15 inches over, but then I need to convert 118 feet to inches. So to do that, I'm going to multiply by 12 since there's 12 inches in a feet, which gives me 1,416 inches. And then the one last thing I'm going to do is I'm going to go ahead and I'm going to reduce that fraction. So I have some smaller numbers. I know each of these are divisible by 3. So 15 divided by 3 gets me 5. And I can check my calculator. 1,416 divided by 3 is 472. So 5 inches to 472 inches. And we definitely want to make sure that we're using our units because of things like this where we get 2 different units. We want to be able to recognize that. So here's a you-try problem for you to do. The next thing we're going to talk about is very similar. There's these things called extended ratios, where now I'm not just comparing 2 values, I'm comparing 3 or more values. And I'm going to write it A to B to C. I can't write it in fraction form because I can't have those 2 fraction bars, 3 fraction bars to compare, so I'm just going to use semicolons here. Now, what's important is that I still really have 3 ratios within there because when I'm comparing all 3 of these values, I can compare A to B, B to C, and A to C. So our first problem is this example here regarding a triangle. And it says the triangle has the sides in an extended ratio of 3 to 5 to 6 and a perimeter of 98. That's important. What is the length of the longest side? So anytime you see this ratio 3 to 5 to 6, if it's talking about a triangle or another shape, what that means is you're talking about 3x, 5x, and 6x. Because that's the simplified version, right? I'm going to have some factor of those numbers being my sides. That some factor meaning the letter x. So anytime you see 3 to 5 to 6, you are going to write 3x, 5x, 6x. Or whatever these numbers are, you are going to write those with the variable x. Now, I know that my perimeter is 98. So if I think about how my perimeter relates to sides, all of my sides added together will tell me my perimeter. So if my perimeter is 98, well, then all I have to do is add those variables up and get 98. Okay, so if I add 5 and 6, 11, I have 14x equals 98. Again, I have to go to my calculator, and I say calculator 98 divided by 14, 7. So x equals 7. But that's not what they're asking me. They want to know the length of the longest side. Well, my longest side is going to be the largest number from my ratio, so 6x. I'm going to plug in 7, so I have 6 times 7 is 42. That's my answer. 42 is the length of your longest side. And then I also have a U-try problem for you to go through. It's very similar to the one that I just did. So now we're also going to take these ratios and we're going to form these things called proportions, which is when we set two ratios equal to each other. So we're forming an equation between two ratios. So when we write these, we're also going to have three forms here, similar to the three forms from our ratios. We could have A to B equals C to D, written as fractions. We could have A colon B equals C colon D. Or we could use the word 2, A to B equals C to D. Now there are certain names for some of these values. I'm going to circle all of the means in orange. That's the middle values within the proportion. So my middle ones are B and C. If you say the alphabet A, B, C, D, B and C are in the middle. Same thing here with the colons, B and C, and B and C. So my middle values are called my means. My extremes kind of make sense. It's like on the way outsides, the extremes. I'm going to go through and get those in like this purplish, I'll go blue. So extremes are the first and last values. So A and D, and D, and D. Those are going to be my extremes, the first and last values. And then the one last thing we're going to talk about is how we solve a proportion. We're always going to solve a proportion by cross-multiplying. Always cross-multiply to find a proportion. Solve that. So let's go through this first example. I'm going to cross-multiply. Get 6 times 4 is 24. 5 times x is 5x. Divide by 5. And I get a fraction, but that's okay. X equals 24 over 5. We don't mind fraction, they're fine. Now I'm just going to leave it as an improper fraction. I'm not even going to reduce it. In fact, on the end of course exam, if you reduce things and make a mistake, well, now you've just lost your points, even though you had the problem wrong or right in the first place. So just leave your fractions, they're fine, don't reduce them, leave it alone. Okay, now here, this is the U-try for you. You're going to go through, you're going to solve that by cross multiplication. And then there's one last thing we have to look at, which are these properties of proportions. Now it's really important that you have these written down into your notes, and we're going to be looking at some examples of them in class, but it's just different ways of manipulating these proportions so that we can use them in different ways. So please list these into your notes as well, and I will see you in class.